All right, it's 1 o'clock. So this is the Part 60 Appendix F, CEMS QA/QC requirements. And I'm also going to go over a few common compliance issues associated with some of those requirements. So let's go ahead and get started. So a little bit about myself. My name is Eric Wiley. I'm a senior air compliance specialist with VIM. Been with VIM for about 3 years. I have a Bachelor of Science from San Diego State in geography. Actually, it was in environmental policy as well. But I've got over 23 years of experience. So I started out after college, I was a source tester, pushing a probe, doing source tests. From there, I became like a project manager. Then I started working at a local refinery in Southern California as a analyzer technician. From there, I became the QA/QC manager and then CEMS program manager at that refinery, and then another subsequent refinery CEMS program manager. And then I got tired of climbing stacks and carrying tools. So I decided to put some of the knowledge I learned to a different use. So I've been doing consulting related to CEMS all over the world. I mean, this job's, I've gone to Europe multiple times, Middle East, Asia. So it's provided me some really cool travel experiences as well. But essentially what I bring to the table is kind of a boots on the ground approach from the equipment itself all the way through the applicable regulations, and sometimes figuring out what's the easiest way to comply with those regulations, because a lot of facilities have limited resources at their disposal. So I help our clients kind of figure out the most efficient way to utilize those resources and stay in compliance. That's the goal, at least. So the first thing we're going to cover is procedure 1. So Appendix F has multiple procedures in it. We're going to just focus on procedure 1, which is specific to CEMS. It's used to evaluate the effectiveness of your quality control and your quality assurance activities to ensure that your data is reliable and accurate. And it's the minimum QA requirement. So what we're going to go over today is the minimum that's required to be done. Oftentimes, to maintain compliance, you're going to need to do a few more QA activities to keep your equipment functioning properly and make sure you're operating in compliance. So it's 2 distinct functions. You have the QA tests and the QC test. So I think of it like a scale. The QA test you're doing to assess how accurate your data is and to assess how well your system is functioning and the data that it's producing to make sure it's accurate. And the quality control are the maintenance activities and repair activities that are in place so that you can pass those quality assurance tests. So the goal is to try and keep those 2 in equilibrium, where you have just the right amount of preventative maintenance so that your systems are performing well and are reliable and providing accurate data, so that you can be confident when you're submitting your reports to the regulators that the data within those reports is accurate. So one thing I hear a lot with CEMS, the definition of a CEMS, continuous emissions monitoring system, but it's the total equipment required to determination of a gas concentration or emission rate. So the way I think of it is, it's from the tip of the probe that's in the stack to wherever your data is being stored. Because if you just have analyzers and they're sending a 4 to 20 milliamp output, or those signals need to be converted into usable data. So you have the sampling system that's bringing the exhaust, removing all the filtering it, removing water from it, sending a clean, dry sample over to your analyzers, and then your analyzers are going to give you a concentration reading, and that concentration reading's going to be used to determine your compliance, whether it's a ppm based limit or a mass emissions based limit, or whatever the case may be. There's a couple other definitions. So the span value, sometimes this gets confusing. The upper limit of a gas concentration of a measurement range. So that's a span value. So oftentimes you might hear technicians call the gases a zero gas and a span gas. So the zero gas is at the bottom of the range. The span gas is up at the top of that range. And so you're demonstrating that the system's accurate at the bottom and the top. One thing I wanted to mention about the CEMS is a lot of times I'll hear my clients refer to their CEMS as they have a NOx CEMS, they have a CO CEMS, they have a SO2 CEMS. Well, actually, you have one CEMS with a NOx, SO2, and O2 analyzer in it, because it's the complete system. So I was talking to a fellow today, and he said they have 90 CEMS at their facility, and I was like, whoa, how big is your facility? But he actually had 30 CEMS systems, but he had 90 analyzers. So it's important to distinguish that CEMS is the whole system, not just a particular analyzer. Calibration drift is the difference between the CEMS reading and the reference value of the gas that you've injected up through the system. So these are the required quality assurance and quality control activities. There are only 4, so it doesn't look too daunting, but there can be there's a lot involved with these 4 activities. So on a daily basis, you have to do a calibration drift check. So you inject gas, a 0 gas, check the 0 reading, a span gas, check the span reading to the concentration that you've injected. Then you have to, the pass-fail criteria, we'll go over in a little bit, but you have to meet certain criteria to pass that calibration drift test. So what the cylinder gas audit is, that's on a quarterly basis. And what you're doing is, remember, on a daily basis, you're checking the bottom and the top of that range. So what the cylinder gas audit does is it checks 2 points in the middle so that you can demonstrate your analyzers are linear across the whole operating range from bottom, 20 to 30%, 40 to 50%, and then 80 to 100%. So that's what the CGA is doing. It's just checking 2 points in the middle. And we'll go over in more detail what a CGA requires. Of course, you have a RATA on an annual basis. And what the RATA is doing is you're comparing your CEMS reading to a certified source tester. So a certified source tester is going to come in, put their probe in the stack, and run the applicable EPA test methods. And then you're going to compare your readings to what they're reading. So they're always the reference. You're always referencing your CEMS reading to their CEMS readings. And then lastly, there's the QAQC plan. So the QAQC plan is required, and we'll go over the details of it, but it's really details the monitoring equipment you have, the applicable regulations and permits, and then what's the equipment that's being utilized. And most importantly, what are the procedures in place to ensure that that equipment functions properly? This is the calibration drift equation. So you see it's the reference value minus the actual monitoring divided by the span of the instrument. It's important to remember it's divided by the span of the instrument and not the span gas value or not the concentration of the gas. There's a lot of words, but really the daily check is the low level, they call it, is 0 to 20%, but I've rarely come across a facility that's not using a 0 gas for their low level. And then the high level is 50 to 100% of that span value. Normally we recommend that span value be around 80% of the range. So that way you can capture the top end of the range. So whenever the calibration drift is 2 times the performance specification, if it's above 2 times performance specification, then you're required to go out and make an adjustment. So let's use NOx for an example. NOx performance specification is 2.5%. So if you do your daily calibration drift check and it comes in at 5.5%, then you haven't failed. Your data's not out of control, but someone's required to go out to that unit, run calibration gas, and then make an adjustment to that unit. And then after they do that, they're required to do another auto calibration drift check. So that's overlooked quite a bit. Whenever I do audits, I'll find that there's not really a procedure in place to go out and make those adjustments. Some places might do it after 2 days. Another place might do it every day, but there's no procedure written for it. So it's important to check, and then that procedure should be included as part of your QAQC plan. So this is a criteria for excessive calibration drift. So this is when the CEMS is considered out of control or the data is invalid. So you have twice the applicable specification for 5 consecutive days. So again, if we use NOx, let's say your NOx is 5.5% one day, you've gone out, made an adjustment, did a subsequent calibration drift check. The next day you do a calibration drift check and it's 5.8% off. As soon as you exceed 5% for 5 days in a row, at the conclusion of that last calibration drift check, the data is considered out of control or invalid, so you can't use it to comply with your emissions requirements. Then secondly, there's a second criteria where if you're 4 times the performance spec over on the calibration drift check, then the data is actually invalid back to the previously passed calibration drift check. So again, if we use NOx as an example, if you're over 10% on any calibration drift check, as soon as you complete that calibration drift check, data is invalid back to the previously passed calibration drift check, and it doesn't become valid until you pass a subsequent calibration drift check. So one thing I notice when we do the audits is sometimes there's no automated look back for the 4X OOC, we call it. So what's happening is we'll find that some of the DASs aren't programmed to go back to the previously passed calibration drift check. So either it's not being done or it has to be done manually. These are just the performance specs for the different pollutants and diluents. You can see it varies. So it's important to know, if you have a CO analyzer and a NOx analyzer and an O2 analyzer all in the same system, they all have different pass-fail criteria based on the performance spec. So it's important to know what the different performance specs are. You can see that for CO, it's 5%. And for O2, it's 0.5% for the performance specification. So when we say 2x for CO, we're talking 10%, or 4x for CO, you're talking 20%. Whereas for NOx, that's only 5% or 10%. So it's good to keep record of the different performance specs. This is kind of what we just talked about. It's when does the out of control period start? So again, if you have 5 days in a row over 5% for NOx, the out of control period starts at the conclusion of the last test, and it stays out of control until you pass calibration drift check. As for the 4x, again, it goes, usually it's 24 hours that it goes back, but sometimes people do cals every 12 hours. There's different durations. It's just important to know when the previous auto cal was passed, because that's going to determine the duration of the out of control period. So out of control period 2, it's not just for your calibration drift checks, but we'll go over, it's pretty much the same for a CGA or a RATA. If you start a CGA, you have to complete it. Once you complete it, if it's out of control, if you fail, then it's out of control until you pass another one. The same is true for a RATA. No, unless you have something specific in like a consent decree, but in Part 60, no, it's just, so what they're doing over those 5 days is they're giving the facility an opportunity to go out and make an adjustment. And then after 5 days, they're like, all right, your time is up. So the data is invalid until you pass, but there's no other penalties involved. You're good. It's just whenever that 5th day ended to the next one. Usually, like if it's a 4x out of control, usually there's going to be some performance issue involved. So it's not just going to be go out and hit the button and do another calibration drift check. Usually if you've exceeded that 10% threshold for NOx, there's something wrong. So there needs to be some diagnostics done to figure out what the problem is. So here's an example of a calibration drift out of control. So you can see it's 5 days in a row, over 6%, but less than 10%. So after day 5, it's out of control until the next calibration drift is passed. But then for the 4x, day 1's 12.5% off. As soon as that calibration drift check's over, it's out of control. Then it goes back to the previous day's calibration drift check until, so usually usually it's like 28 hours, you fail the cal and it takes a technician 4 hours to get out there and they pass it. So it's that 4-hour period plus the previous usually 24-hour period. So it can really affect your analyzer data availability. So keeping from having those 4-day performance 4x failures is pretty important. So again, if data is out of control, you can't use it to demonstrate compliance with your emissions limits. And so quarterly, you'll have to do like a data assessment report or EPA report, and that's going to include your CEMS downtime and your excess emissions. And so that's where this out of control data comes into play. So it's important to ensure that your technicians know as well, and the timing is right so that you can put this downtime into the proper bucket. So that's why the communication between the instrument team and the environmental team is pretty important. Again, like I said, if you fail a CGA or a RATA, data is out of control until you pass the next one. So that can be a big deal if you fail your RATA and it's late December and the source testers are booked because everyone waits till the end of the year to do their RATAs and you can't get them in for a month. That means you have downtime for a whole month. There's going to be consequences for that. So keep that in mind when scheduling your RATAs. Try and leave a little room towards the end of the year if that's when you do it, so that you can try and schedule someone and get them out there. I mean, I always try and recommend a do your RATAs in like the third quarter, first, second, or third quarter, and try and avoid the fourth quarter. So there's another finding that we have a lot is you can't do any of your QA tests. They have to be 60 days apart or 2 months apart. And so when I do audits, I'll just compare the CGA to the last CGA or the RATA to the previous CGA. And often I find it's like 58 days or 57 days. It's not quite 2 months. So it's something to, if you're using like SAP to schedule these tasks, or if you have some other mechanism that you're using to send out these work orders, ensure that they're separated by 60 days or greater. So this is just describing what a CGA is. You do a CGA in 3 of 4 calendar quarters, because in the other quarter you're doing your RATA. It's not required if the unit doesn't operate. So if it's quarter 3 and the unit that the CEMS is on doesn't operate, then you don't need to do a CGA. But it's important, CGAs, the unit doesn't have to be running. So I would still do, because what if at the last few days of the quarter, the unit fires up and you're scrambling to get your CGA done? So it's one thing to remember is the unit does not need to be operating to do the CGA. You can see the percents, 20 to 30% or 50 to 60% of rate or of span. So again, just think every day you're checking the bottom, you're checking the top, and now you're checking 2 points in the middle. And then each gas you inject 3 times. So usually you'll go the low mid, inject it for a while, get a response, capture that data, then inject the high mid, let it flow for a few minutes. I know when I was instrument check, I tried to do it as quickly as I could. And oftentimes that would result in not getting enough data. So just let the gas flow for a little while, let it stabilize. So what I've found too is for compliance related issues in CGAs is the gases that have been used are not within that 20 to 30% or 50 to 60% of range. So I had a huge client that they bought all the same gases in bulk for all their facilities because they had the same ranges. And the low end gas was like 19.2%. And so they had a big issue. I mean, from a logical point of view, they passed the CGAs, with the gases they used. But since the gases weren't up to what's required, those CGAs were considered invalid. So they had to redo them. And in turn, they had to pay a fine to the EPA. Make sure the gases aren't expired. I unfortunately have used gases that are expired because it's kind of easy to do. You're only using them once a quarter. So maybe in quarter 1, you see that it's going to expire towards the end of that quarter, but forget to get a new gas for the next quarter. So it's something to try and stay on top of. So the gases need to be EPA protocol gases. I'm not sure if you guys use the same EPA protocol gases for your daily cals. Most facilities that I've been to do, but it's not required for your daily gases. It is required for your quarterly CGA. You want to make sure the gas goes all the way up to the probe, follows the whole sample system down through your conditioning system over to your analyzers. You can't do the same gas twice, so you can't go the low mid gas and then turn it off and wait for it to go back to process and do low mid gas again. You need to alternate the gases. The pass-fail criteria is 15% plus or minus, or 5 p.m., so whichever is greater. I think it's important to note too that the pass-fail criteria is 15%. So the first goal obviously is pass. But if I do a CGA and I'm off by 12%, then once I'm done with that CGA, I'm gonna go in and have a look at my system and see what's causing that 12% difference. Because remember, on a daily basis, you're just checking the bottom and the top of the range. There might be something going on in the middle that you're not aware of. This is just the equation. This is straight out of part 60. You can see it's the CEMS response minus the audit value divided by the audit value. So remember before, you divided by the span and not the value of the gas. For the CGA, you divide by the value of the gas that's being used. It's a very complicated drawing that my 6-year-old son did. You have a CEMS, you have a test truck, you're comparing the emissions. It's important to match up the response times because you want to be checking the same gas at the same time. So if the response time to the CEMS is 1.5 minutes, and then the response time to the test truck's 2.5 minutes, then you're not comparing the same emissions at the same time. It might not be that important, but if your emissions are fluctuating, kind of going up or down, you might be at a trough and they're at a peak, and that could be the difference between passing and failing. So for a RATA, it's a minimum. Each run is a minimum of 21 minutes. You have to do at least 9 runs, but you can do more. Then you can throw out up to 3 runs. So if you do more than 12 runs, you need to include those additional runs in your average. Sometimes I always recommend my clients do at least 10 runs, excuse me, because you never know when something could go wrong that you don't capture while the test is happening. So if you have an extra run in your back pocket, I know it takes, a half hour or 45 minutes more, but you always have an additional run. That way, in case something went wrong with their data system or with your system, you have another run that you can use, and you can toss out the one where something went wrong. It's important to your 50% of normal operating load. So you need to know what your normal operating load is, and just ensure that you're at least 50% of that operating load when the RATA is performed. So this is the equation for the relative accuracy. I think the thing here is it's not just a direct comparison of numbers. There's also the confidence coefficient that's involved here. So even though if you're seeing what source testers numbers are and you're seeing what your numbers are, if they're very close, it doesn't matter. But if they're far enough apart where you think you're at 18% or something along those lines, remember there's also a confidence coefficient that goes into that calculation. So you need to do a little additional math to make sure that you're passing. If you're failing, you're failing. But it's important to know that it's not just a direct comparison. Again, you have different performance specs for different pollutants and the diluents. So the performance specs are different for the relative accuracy as well. Just like they were different for the calibration drift, they're different for the relative accuracy. So you can see it's 20% plus for NOx and for NOx and SO2. But there's also that 10% of the emission standard. So that's often utilized at like power plants where their limit is in pounds per million BTU. So it's a very small decimal. So the smallest difference in numbers can result in a large percent off. So that's where that 10% with the emission standard usually comes into play. But again, look, it's for O2, 1% absolute's usually what's used. For CO, it's only 10%. So it's important to know these differing pass-fail criteria for the different pollutants for the relative accuracy. It's not the same for every pollutant, and sometimes we'll come across that. Another recommendation, if you will, if you're having issues, before you start your RATA and the numbers aren't matching up, just look at whoever's oxygen is reading higher. It's like 85% likely that the problem lies on the system with the higher O2 reading. That's my experience from being a source tester and running CEMS programs. Whoever's O2 is higher is usually where you're going to find some sort of issue with the system. These are just for, if you have a continuous emissions rate monitoring system, you stack flow monitor. It's got 20%, and then VOC or total vapor phase mercury. So you can get all this information. Obviously, you'll get a copy of this presentation, but it's easy to find in Appendix F. I'm sorry, these are in Appendix B. So you begin the out of control period for the CGA or RATA. This is a little repetitive. Again, the important thing to know is if you start a RATA, you have to finish the RATA, even if you know you're failing. If you start a CGA, you have to finish that CGA, even if you know you're failing. So why that's important is you want to make sure for your RATA, you want to make sure that you want to start. Just don't willy-nilly, okay, let's start, it's time to go. Like, make sure you're good to go, because once you start, you have to complete the test, and if you fail, you fail. So, and same thing with the CGA. When I was a technician, I didn't know that you had to, if you started a CGA, that you had to finish it. But many times I'd start a CGA, seeing that it was gonna fail, and I would just start my corrective action then. But you really need to complete the test, then do your corrective action, and then redo the test. So I got this question quite a bit. What happens if the CGA or RATA is not performed? And there's not really a single definitive answer. It depends where you are. Where I'm at in Southern California, South Coast Air Quality Management District, if you have a, let's say it's Q3, June ends and you haven't done your CGA, data is invalid until you complete your CGA. Same thing for a RATA, but it varies from state to state. At a minimum though, you're gonna not be required, you're not gonna be complying with your permit conditions. If your permit conditions say comply with Part 60 Appendix F, then in Appendix F it says you got to do it every quarter, and so that's where it comes into play. So it's important to kind of get an understanding of wherever your facility's at, what's the regulator's response to this? Because I've been at other places that they're just like, it's only a couple days, don't worry about it. I haven't seen it that often, but I've seen it once. So it's good to get that information beforehand. So this is another important one. I keep saying the same thing, but if you have two inaccuracies in 2 consecutive quarters, then there needs to be a response. You know, this is straight from the rule. It says the source owner or operator must revise the current written procedures, modify or replace the CEMS to correct the deficiency causing the excessive inaccuracies. So let's say quarter 1, you fail your CGA, make some corrective actions, pass it. Then quarter 2, you fail your CGA, make some corrective actions and pass it. That's 2 quarters in a row where you failed a QA test. So there needs to be some documented response. Most often it's going to be updating procedures so that it's really showing that you're taking a more active quality control activities or updating the maintenance of the units. But the main thing is to document what's been done, because an inspector will, if they see that, they can ask, okay, what was implemented after these 2, QA tests were failed. Then also you should keep a procedure as part of your QA/QC plan. So this is the QC requirements, or what's required in a quality control plan. It doesn't, there's 6 items. It doesn't seem like much, but I've yet to come across a quality assurance plan that's totally compliant when we're doing audits. There's always something missing. So you need step-by-step written procedures for calibrating the CEMS, determining the calibration drift, adjustment of the CEMS. And here's usually what's missing is the preventive maintenance activities. So if you have any scheduled maintenance activities, maybe every quarter you rebuild a sample pump or change a probe filter or flush out the sample line. If you have these preventative activities, and you need to have step-by-step procedures for each of them included in your plan. And also you're required to have a spare parts inventory. But remember, it's a spare parts inventory of what you actually have, not a list of the recommended spare parts that you don't have. I'll say 80% of the QA/QC plans, obviously ones I didn't write, but 80% of the ones I do audits on, it'll just reference recommended manufacturer spare parts. Well, that's not the intent of the spare parts inventory. It's to show what do you have on site so that you can make the repairs quickly and when necessary. And the last one too here, program of corrective action for a malfunctioning CEMS. Sometimes it can be as simple as just how does the information flow and when does the loop close? Okay, operator gets an alarm. Operator contacts the instrumentation lead. He sends somebody out there. They attempt to remedy the problem, or they do remedy the problem. They let operator know, and then they contact environmental. It can be as simple as something like that, but there needs to be a procedure of what's being done once a malfunctioning CEMS is discovered. So this is just like what I think should be in the QA/QC plan. It's you want your applicable permit and your emissions limits and the applicable regulations, the CEMS responsibilities. So usually I'll insert a table in there that just has the title, not the person's name, but title. And then what are their responsibilities associated with the CEMS? So if it's the plant manager, his responsibilities might be sign the quarterly reports or something to that nature. And it can go all the way down the line until if you use an outside contractor, you can say enlist the help of contractor when problems arise that the instrumentation team can't figure out, something along those lines. But use titles and then have a pretty descriptive. So this way too, everyone knows what other people are responsible for. So they can look at this, I call it a CEMS responsibility matrix. And if they encounter a problem, they might know just from that table who to contact next so that they can try and resolve that problem. And then just procedures. I'm doing another one later. It's called common audit findings. But what I find a lot, especially at facilities with just 1 or 2 CEMS, is that one guy knows everything about the CEMS, and then that guy retires. And then the company's in a bind because they didn't document this person's, he has a lot of knowledge, so document it. And that way you can use the QA/QC plan as a training tool as well. I see it way too often though, where, oh, Bob, man, he knew everything about that system, but he quit 2 months ago, so. This is some common pitfalls. So no QA or maintenance procedures, or very few. No response to a malfunctioning CEM. No delineation of responsibility for the CEMS. No spare parts list, or the spare parts list is just the manufacturer's recommended spare parts, and it doesn't reflect actually what's maintained on site. Lack of all applicable rule requirements. So some facilities might be Part 60, but they might have some Part 75 obligations as well. Or if you think of a power plant, it's got Part 75 and then Part 60 for CO. They have some different QA/QC plan requirements. So what I think should happen, integrate those all together so you have one comprehensive document. Or the plan's not understood, where the plan is simply there to try and comply with the regulation and it's never been passed over the eyes of people who actually do the work, usually the instrument techs or the instrumentation team. So with that understood, they don't understand what's in it. Part of the time it's because there's no periodic review. So I always recommend annual review of your QA/QC plan. You can make improvements to it. You can make it an actual tool to help your program when people come and go, and it's a good training tool. The second refinery I worked at, we had guys from everywhere, some with lots of CEMS experience, some with no CEMS experience. So me and some of the more experienced guys, we got together and put our brains together and wrote a pretty thorough QA/QC plan, and mostly it consisted of procedures. And then the way I made sure the procedures was good is I would give the guy who I knew didn't know how to do it, I'd say, here, let's go see if you can do this. And without fail, there'd be shortcomings in my procedures, but giving it to someone who doesn't really know how to do it, helping them figure out how to do it, then you include those details and stuff. You know, I would leave out steps in the menu and the analyzer or stuff like that. So the goals of your QA/QC plan are compliance, first and foremost. You want to combine the regulatory disciplines in one comprehensive document. You want clearly define procedures, and you want input from all parties. So when I say all parties, essentially that means environmental, instrumentation, and a little bit from the operators. Not too much from the operators, but a little bit. And then you can use it as a basis for training. And I think it can be, if the proper information is included, it can be a really useful tool. I know it was for us. That's it. You guys have any questions? Mm-hmm.